Hey guys, Mr. Backerwick here. In this video, we're going to be looking at finding the greatest common factor. Now, before we get into actually factoring out our problems in this video, I want to remind you about the quotient rule for exponents. So we've got a division problem happening here. We have 12x to the fifth being divided by 4x squared. Now, as we look at breaking this up, we're going to do the numbers first. So 12 divided by 4 is going to give me 3. Now, as far as those x's go, the quotient rule for exponents says that when you divide the same variable, you want to subtract the exponents. So we're going to do the top power minus the bottom power. So we're dividing x's in here, so this 3 is going to have an x attached to it. But if we look at the powers, we're going to do the top power, so 5, minus the bottom power, 2, and 5 minus 2 is 3. So when we divide this out, we get 3x cubed as our answer. Now, as we're taking a look at these examples, we're going to be finding a greatest common factor, but then we're going to be taking it out of our polynomial. It's called factoring out a GCF. So we've got 12x plus 42y. And the first thing I want to do is figure out what the greatest common factor is. So let's look at this 12x first. I'm going to look at the 12. 12 could be 2 times 6. Now we still have this x attached, so I'm going to put times x on the end. 6 can be broken down further, so I'm going to leave this 2 in front, but 6 can be broken down into 2 times 3. And then we still have this times x on the back end. So if we look at breaking 12x all the way down, it could be 2 times 3 times x. Now let's talk similarly about the 42y. Now 42 could be 6 times 7, and we've got this y, so I'm going to put times y. 6 breaks down. 6 is 2 times 3, but then I still have this times 7, and I have this times y. So when we're looking for a greatest common factor, we're looking for the things that are common to both factored out forms. So if we look, we have 2's in common, so I'm going to take the 2, and I have 3's in common, so I'm going to take the 3. And we're going to multiply those common factors together. So the greatest common factor between 12x and 42y is 6. But we're not done. What we're going to be doing with that GCF is taking it out of our polynomial. And it's kind of like the reverse of the distributive property. So we're taking this 6 out, and we want to figure out what's going to be left over when we take that 6 out of there. And this is where that quotient property is going to kind of come into play. When you take out a GCF, what you're really doing is dividing your starting things by that GCF. So if I want to take a 6 out of 12x, I need to divide it by 6. Well, if I take 12 and divide it by 6, I get 2. Nothing happened to this x, so it's still going to be attached to that 2. And then if I want to take the 6 out of the 42y, I need to divide that by 6 as well. And 42 divided by 6 is 7, but that still has the y attached to it as well. So we factor out the 6, leaving us with 2x plus 7y. Now this is actually going to be your final answer, but I said that factoring out a GCF was kind of like the reverse of the distributive property. So one thing that we can do to check our answer is try to redistribute that thing that we took out, and it should give us back the original polynomial that we started with. So I could multiply this 6 back in to check to make sure that I do get that polynomial that I started with. But our final answer, like I said, is 6 times 2x plus 7y. Now, as I look at this example, I've got 4x to the fourth plus 24x cubed. I want to look at breaking down that 4x to the fourth first. 4 is 2 times 2. X to the fourth is x times x times x times x. Now, as far as that 24x cubed, if I break 24 down, that's 4 times 6. 4 is 2 times 2, 6 is 2 times 3, and x cubed is x times x times x. Now, I'm looking for a GCF, so I'm looking for what they have in common. I see one set of 2's, so I'm going to take a 2. I see another set of 2's, so I'm going to take another 2 out. And then I see 3 sets of x's that I can take out. So x times x times x. So if I put all this back together, 2 times 2 is 4. x times x times x is x cubed. So 4x cubed is my GCF. So I'm going to take that and I'm going to write that in front of my set of parentheses. But to figure out what's left over on the inside, I now need to divide each of these pieces by that 4x cubed. So I'm going to start with the 4x to the fourth, and I'm going to divide that by our GCF, 4x cubed. Now, 4 divided by 4 is 1, but I don't really need to put the 1 in front of my variable. If I look at the variables, I've got x to the fourth divided by x cubed. Our quotient rule for exponents says that when you divide the same variable, you subtract the exponents. So if I take x to the fourth divided by x cubed, 4 minus 3 is just x. And again, we said we don't need to put the 1 in front, so we're good there. Plus, now if I take that 24x cubed divided by 4x cubed, 24 divided by 4 is 6. Now if I look at those x's, x cubed divided by x cubed, well, if I subtract 3 minus 3, I get 0, telling me that there are no x's left over with this. So my final answer is 4x cubed times x plus 6. And again, I could use my distributive property to distribute that GCF back in, and it should give me the polynomial that we started with. Let's look at a couple more examples here. So we've got 14m plus 35n. So 14m, if we look at breaking that down, 14 is 2 times 7, but I have the m attached, so times m. If I look at 35n, 35 is 5 times 7, but I have the n attached. If I look for what they have in common, they each have a 7. So the GCF that we're going to take out is 7. So if I want to take the 7 out of the 14m, I'm going to divide it by 7. 14 divided by 7 is 2. I don't do anything with the m since I'm not dividing by any m's. Plus, if I take the 35n and divide that by 7, 35 divided by 7 is 5. I'm not doing anything to the n, so the n stays attached. So for my final answer, I get 7 times 2m plus 5n. As I look at this example, I've got 8y cubed plus 12y squared. Let's look at the 8y cubed first. 8 is 2 times 4, but 4 breaks down, so we have 2 times 2 times 2. Y cubed is y times y times y. If I look at 12y squared, 12 is 2 times 6, but 6 breaks down, so we have 2 times 2 times 3, and y squared is y times y. If I look for what they have in common, I see one set of 2's that I can take out. I see another set of 2's that I can take out, and I see 2 sets of y that they have in common. So times y times y. Well, 2 times 2 is 4, y times y is y squared. So my GCF that I'm going to take out is 4y squared. But I need to figure out what's left over, so we're going to do our dividing. Let's start with the 8y cubed divided by 4y squared. 8 divided by 4 is 2. Y cubed divided by y squared. I want to subtract those powers. So 3 minus 2 is 1. So we get y, but I don't really need to put the first power on there. Plus, now if I look at the 12y squared divided by 4y squared, 12 divided by 4 is 3. Y squared divided by y squared. 2 minus 2 is 0, so that tells me that there are no more y's attached to that. So my final answer is 4y squared times 2y plus 3. Just a few more examples here. So on this one, we've got 16a squared minus 40b. I'm not going to run through and factor it all out, but I know that this one is going to have a GCF of 8, meaning that I'm going to try to take 8 out by doing that dividing. So if I want to take 8 out of 16a squared, I need to divide by 8. Well, 16 divided by 8 is 2. I'm not dividing by any a's, so I don't need to change the a squared. Now, if I try to take an 8 out of a negative 40b, I need to divide that by the 8. Negative 40 divided by 8 is negative 5, and I'm not dividing by any b's, so I don't need to change that b at all. So my final answer is 8 times 2a squared minus 5b. As we look at this next example, we've got 9x and y squared plus 6x squared y. If I'm looking for the GCF, it's going to be 3xy. So I'm going to take that out of my parentheses, but I still have to figure out what's left over. So I'm going to start with the 9xy squared, and I need to divide that by 3xy. Well, the first thing I need to do is 9 divided by 3. 9 divided by 3 is 3. I'm going to look at those x's next. On top, I have an x to the first. On bottom, I have an x to the first. So x to the first divided by x to the first, 1 minus 1 is 0. So there's no more x's left. Now, if I look at the y's, y squared divided by y to the first power, well, 2 minus 1 is y to the first power, but I don't really need to put the first power on that y. Plus, now if I look at that 6x squared y, I'm going to divide it by the 3xy GCF. 6 divided by 3 is 2. If I take x squared and divide it by x to the first, subtracting those exponents, I get x to the first power. But again, I don't really need to put the first power on there. Then if I look at the y's, y to the first power divided by y to the first power, 1 minus 1 is 0. So that tells me that there are no y's attached to my final answer. So I get 3xy times 3y plus 2x. Now, in this last example, we've got 3 terms, but the process is still exactly the same. We would want to find the GCF between all 3 terms, and then we're going to factor that out. So if I look at what we've got, the GCF is going to be 2n cubed. So I'm going to take 2n cubed out, and in order to do that, I'm going to have to divide all 3 of these things by that 2n cubed. So starting with the 4n to the 5th, dividing that by 2n cubed. 4 divided by 2 is 2. N to the 5th divided by n cubed. Subtract those exponents and I get n squared. Now if I go to the middle, negative 22n to the 4th divided by 2n cubed. Negative 22 divided by 2 is negative 11. N to the 4th divided by n cubed. Subtract those exponents and I get n to the 1st. Now lastly, I have this negative 8n cubed, and I'm going to divide that by 2n cubed. Well, negative 8 divided by 2 is negative 4. N cubed divided by n cubed, 3 minus 3 is 0, so there are no n's attached to my final answer. So I get 2n cubed times 2n squared minus 11n minus 4. That's going to be it for this video. Thanks for watching.